Good morning, all of you. So today we are going to learn one method that is called parallax method. What is that? Parallax method. What is this parallax method? If we will take a pencil in our hand, we will keep at some distance from the eye, and if we closed one eye and saw the position of pencil, you will get its position at one point, or one position it will show. Next, now close another eye and see. Again, you will feel that the position of pencil is little bit changed. This is called parallax. What is this? Parallax. In simple words, when we are closing left eye, you will get one position, or you will feel that there is one position of pencil, and when we are closing right eye, then it will feel that it has changed. So this is called parallax. Okay, and the distance between our two eyes is called basis. Distance between two eyes is called basis. Okay, so first of all, what is this parallax? Or what is the use of this parallax method? Because parallax already I have explained you. So what is use of this parallax method? Method is used to measure large distances. Large distances which we cannot measure with meter scale. With meter scale. For example, distance of stars and planet. Distance of stars and planet. Got it? So I am drawing one diagram here, how we are going to use this method. Now this is suppose distant object, we can say star, and these two are the positions on the earth, and this d is what? Distance between the star and the first position, or you can say just distance between the star and the from earth, because we are watching from earth. So this is star and these 2 points are on the earth, so this distance is also d only. right? So here I am writing, what is this? A and B are two positions on the earth A and B are two positions on the earth from which we observe we observe planet. Yes. Okay. Next, D is what? Distance between distance between A and B. That is in bracket what? Two positions from which we are observing. Distance between two positions. Okay. Capital D is what? Distance between planet and Earth. And this angle now. This angle is theta, and this theta is called parallactic angle. Theta is what? Parallactic angle. Or even you can say it as a parallax angle also. Or parallax angle. Okay. Now let's move ahead. As this capital D is very long, or we can say it is much greater. Yes or not? Or because planet is far away. So as D is very large distance, B by capital D will come very less than 1. You can see here. This is very small as compared with this, right? So therefore, B by D is very less than 1. Then whatever this straight line is there, or whatever this small arc is there, it is like it will become like a straight line. For example, I will tell you one thing. See, this is a big circle, okay? And now suppose here it is a center, and from this, if you are considering very small angle, see here, very small angle, this one, can you see here, this angle? Now you see here, this is your arc, but it is behaving like a straight line only, yes or not? Because this angle is very small, this angle is very small, that's why this will create as a straight line only. Understand? Same thing here also, because this distance is very long. What happens in this case? You can see here, this D is like a straight line, you know, instead of arc. So therefore, from the diagram, this AS is equal to BS, which is equal to D. AS is equal to BS is equal to D, and AB is equal to small d. Then can I write like this? This B is equal to capital D into theta. What did you see? B is equal to, but here I have taken it as a D, है ना? Okay, so I will take here also D only. 1 minute. This is D. Small d I have taken. So here I will write D is equal to capital D into theta, and therefore capital D is equal to this small d by theta, because in the diagram we have denoted it with a small d. What we have denoted with small d, you know. How you are getting this, sir? Why there is we are not using, means you see, if we know this formula, angular displacement in the mathematics, angular displacement is equal to what? Arc by radius. Take it. Angular displacement is what here? Theta. Arc is what going to be? Arc क्या है? Small d. Radius क्या है? Capital D. And therefore d is equal to capital D into theta, because this arc is nothing but what? Small d, because the angle is very 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 small, and therefore you got d is equal to capital D theta, and therefore capital D is equal to small d by theta. Okay, so from this formula we will get distance. Okay, from this formula what we will get? So from this we can calculate capital T, that is distance between earth and planet. Okay, got it? This is what your capital D is, distance you calculated. Okay, now next note point here you see. Now note point. Now see, this was the previous diagram. Okay, and now assume that this is your earth. Okay, this is earth now, and this is what its diameter. Yes or not? And now this is angle is alpha. This angle is alpha, and as we have calculated, this is a d, and now I am taking this as again small d. Okay, this is diameter of earth now. In this case, d is what? Diameter of this earth. Here it is earth now. Okay, this point I am taking as a, this point I am taking as a b. This is yes, same, everything. Okay, but now I want to find diameter of earth. If d is diameter of earth, then what we will get below? Alpha is equal to small d by capital D. Alpha is equal to small d by capital D in this case. So see here in this diagram, this was just two random points on the earth. But if suppose now once we got this distance and we want to find the diameter of the earth, then we can use this angle, this formula also. That is alpha is equal to small d by capital D for finding the diameter of this earth. Understand? Is that clear? So instead of earth, any planet you can take. So diameter of any planet we can find out from this method. We will solve one example, then you will understand how it is. Okay, right? So let's see one small example. If you have IP textbook or NCRT textbook, in that you will get solved examples on this model. You can once go through that, open the book and just go through it. You will understand easily. It is very easy there. They have given, right? You can solve. Just note down at least if possible. Example 2.3 and example 2.4. Okay. Example 2.3 and example 2.4. So out of that example 2.4 I am solving here. You solve 2.3. IP textbook I am writing also here. Already solved example is there. Just for understanding the concept, let's solve this. So see what is the question. The sun's angular diameter, the sun's angular diameter is measured to be 1920 seconds. This is second, okay. The distance d of the sun from the earth is the distance d of the sun of the sun from the earth is 1.496 into 10 to the power 11 meter. What is the diameter of the sun? What is the diameter of sun? What is the diameter of sun? So we have to find diameter of the sun. So now here what he is asking, now I will draw a small diagram. Now this is suppose earth, okay, see here carefully, it is very easy, and here it is sun, this is sun, and now what we have to find, diameter of this sun we have to find. So these are the 2 points like this, giving here as a sun, this is sun, and let us suppose this small d is what, diameter of sun, right? What is this, small d, diameter of sun, and this is the d, distance from sun to the earth, and this angle they have given, okay? This angle they have given, how much they have given, 1920 seconds, okay. Now how to find this, how to solve this, very simple. First of all, this alpha is given, alpha is how much, 1920 seconds, so we have to convert it into radian. So there is one factor to convert into radian, 1920 into 4.85 into 10 to the power minus 6 radian. This is what alpha we got. Again what is given, capital D is given, hai na? Distance, so capital D is also given, 1.496 into 10 to the power 11 meter. And what we have to find, we have to find just a small d is equal to how much. Now what is our formula, d is equal to alpha into capital D, yes, small d is equal to alpha into capital D. So let's see now, alpha value whatever it is, substitute 1920 into 10 to the power, or 4.85 also I will take one time only. So therefore here you are getting 1920 into 4.85 into 10 to the power of minus 6 into This is capital D. So 1.496 into 10 to the power of 11. So this and this will get cancelled. So it is here 5. And now if you will multiply this, multiply, how much you are getting? Check it. So its answer is coming 1.39 into 10 to the power 9 meter. This is what? Small d. That is this diameter of sun. Okay. So one more problem is there. That is homework for you. I am writing here. Homework. You just go through that. That is example 2.3. From IP textbook. Okay, immediately you solve this. Don't forget, just go through that. It is already solved. Okay, so please don't forget this homework. Just go through this at least and try to solve. Okay, so let's stop here for today. Bye.